Hey everyone, sorry that I'm missing class today. I'm homesick, and I'm gonna try and do this note as quickly as possible and with as minimal talking as possible. So please feel free to pause the video as much as you need to um, in order to get the information that you need to get from it. Today we're gonna finish up the unit on exponents and logs talking about growth and decay. Now, exponential growth occurs when quantities increase or decrease at a rate proportional to quantity present. Basically, it occurs in examples such as savings account, population sizes, quantity of decay of radioactive chemicals. These are all perfect and great examples of an exponential function. How it can be used in the real world. Now, if this is the general formula for exponential growth and decay, A is the initial amount. B is the growth or decay rate. Um, if the growth rate is a percentage, then you want to add it to 100, and if it's a decay rate, you want to subtract it from 100. So just keep that in mind. And t, of course, is the time at which it's happening. Now, example number 1 talks about um, the endangered species of an animal in a game reserve, where n of t is the number of animals alive in t years, and we're talking about their initial population at the beginning. So if I want to talk about how many animals are there at the beginning, time is 0. So n of 0 is equal to 150, 1.05 to the 0. We'll notice that that's just 150, so I could have just taken the number from there. So 150 animals were there at the beginning. How many are there? Or by what rate is it growing? Well, by what rate is the population growing? Well, it's growing by 5% per year. And the reason that I know that is the 1 in front of 1.05 is the 100%. So I want 100, and then the 5% on top of it is the rate at which it's growing. How many animals are present in 2 years? That's n at 2, which is 150, 1.05 to the 2, which is 165.4. So in 2 years, there are approximately 165 animals. You can't say 166 because this 0.4 of an animal hasn't actually happened yet, so only 165 is what you can say. How long will it take for the population to triple in size? Well, if I started out with 150 animals, that means I want to get to 450 animals. And I have 150, 1.05 to the t. T is what I want to find. Well, notice I'm now going to use my exponent rules and my log rules. I'm going to divide by 150, and I get 3 is equal to 1.05 to the t. What I want is in the exponent. How do I get out of the exponent? Take the log of both sides. So log 3 is equal to t log 1.05. T is equal to log 3 over log 1.05. Use my calculator, and I get 22.5. Therefore, it takes approximately 22.5 years in order for the population to triple. In the next example, we have an antique vase that is purchased in the year 2000 for $8,000. The vase appreciates in value by 6% per year. Appreciates means it gains money. So t is the number of years after 2000, because the year 2000 is when this starts. So what is the expected value or the estimated value of this vase in the year 2040 to the nearest dollar? Well, I'm going to start at the beginning, and I need my equation. N of t is equal to 8,000 is how much it starts at. My rate is 6% added to the 100, so 1.06. And 40 years have passed from 2000 to get to 2040. I use my handy-dandy calculator, and I get 82, 285, 74. So this vase to the nearest dollar is approximately $82,286. That's a lot. It says you decide to put it up for auction when the price reaches $20,000. When will this happen? So I want to get to 20,000 is equal to 8,000, 1.06. Again, I'm trying to find t. So I divide by 8,000 and I get 2.5 is equal to 1.06 to the t. What I want is in the exponent. How do I get an exponent? Well, I take the log of both sides. So log 2.5 is equal to 2 log 1.06, sorry. So t is equal to log 2.5 divided by log 1.06. I use my handy dandy calculator and I get 15.7. Therefore, it gets close to $20,000 around 2015. If I want to get a little bit over $20,000 for it, I'm going to sell it in 2016. So therefore, it will be approximately $20,000 in the year 2015, but over, or slightly over, $20,000 in 2016. Next example talks about the rate of caffeine and that it's eliminated from the bloodstream of an adult is about 15% per hour. Sorry about that, I had to sneeze. I said, sorry, the rate of caffeine is eliminated from the bloodstream of an adult about 15% per hour. An adult drinks some caffeinated soda and the caffeine hits his or her blood and reaches a peak level of 30 milligrams. How long will it take for 5 milligrams to remain in the bloodstream? Well, I'm going to start with my original formula. F of t is equal to a b to the t. Well, this time I start with 30 milligrams, and because I'm losing my caffeine level, it's 100 minus the 15, which is 0.85 to the t. Notice that this is the amount or the percentage remaining in the bloodstream. I want to know when it's going to get to 5. So again, I'm now going to divide by 30 and I get 1 over 6 is equal to 0.85 to the t. What I want is in the exponent. I take the log of both sides in order to get out of the exponent. So log 1 over 6 is equal to t log 0.85. So t is log 1 over 6 divided by log 0.85. I use my calculator. I get out about 11 hours. So it takes around 11 hours to get to about 5 milligrams in their bloodstream.